I guess high level, what we were trying to do here is basically take this conceptual diagram and turn it into what would a database actually, like what would a relational database look like?
It's rather your use case.
When I'm converting it to relational schema,
you're using the steps.
We are doing something extra.
Like yes, in the steps, but from database perspective, it's there.
Yeah, I might be wrong using that word, but since we're converting to relational schema, so I adding the temporal because we have to do some extra work here.
Oh, yeah, that's for sure.
Okay, so yeah, the fact that you say temporal, for me, that would mean immediately that if I have a temporal conceptual schema, that means I'll immediately have things like start time, end time. Right away, I know I'm going to have a bunch of start time, end time things. Where if I had a non-temporal database, I wouldn't have those types of things, and I would not have the same number of tables because I'm having relations just to keep track of the temporal side of things. Okay, cool, great, high level, that makes sense.
If you want to understand it, we should use the lab notes.
In this model, the principal concept is the relation table. Sure. The entities, the association by relations. Okay, model, relation, keys. Okay, so key, this makes sense to me. This is the same as like any key in other relational database. I'm saying this is the thing that's my unique identifier, right? And then I have an attribute, which is just something that's in my relation. And then if it's italics, it's an optional attribute. It sounds optional. It sounds like it's wrong. It doesn't, we've never seen it. It's fine. Okay, multi-valued attributes. So this means that I have an author, and there's either going to be one or more authors, but at least one. This 1 to n, right? Is it always just giving me a min and a max number of authors that I'll see for each book?
No.
For me, I understand from that, it can be from one to many relation.
Relation to book?
This is book.
Yeah.
A book can have one to relation with the author is many. Like a book can have many authors.
Okay, so it's not so much that there are one or many authors, it's more a relation of one or one to many.
One to many.
I guess when you say one to many, it could still be a one-to-one if you just happen to have one author. So I can say one to many, and that's the constraint I put on my relationship.
Yeah,
even though it could end up having one author, but my constraints allow for many.
Okay. Even it could have no author.
No, not for this though, because this is
author would have a book. Okay, yes. So it's not possible to have no author.
Okay. So then, multi-valued attributes. Did anything change from this to this? No. He just wrote down that to represent this table, I would have the name of the table is livre. I have ISBN is red and underlined, and then I'm adding the attributes author. And then because I have a one-to-many relationship, I'm adding, now is this this is just now putting in my references. This is putting in my constraints that I will have I got that wrong. He created a new table called livre auteur, so a book author, that uses ISBN and the author as a key. And then for this second table, he defines that this is where things get confusing, that the ISBN of this table right above it references the ISBN of this parent table.
Yes, this is the foreign key constraint.
Yes, when you have one-to-many relation to relate the parent to child, you have to use the primary key of parent into child table as a foreign key.
The primary key of the parent into, and this is the child table, did you call it?
No, I don't know, it's child table. It can be another table.
Okay.
Which are relating the parent and child, the intermediate table.
So there's a table. So what's another table that's relating?
Author.
So I have a table of authors, I have a table of books, and I have an intermediary called book author that relates the two.
No, because why I'm saying that, because of that table. Because he is using this table's primary key and author table's primary key as a primary key.
No, I don't think he's using primary key. I think
ISBN
using
is
the name and ISBN as a combination, but I
Yes.
think that is the name. Like that's not. He's not connecting two tables, because what you are saying could make sense if there are lots of information of the authors and you don't want them to repeat unnecessarily.
It happens only
Yes.
in the case if you want to uh, join relate to table with the intermediate table,
Hmm.
and that intermediate table will have parent primary key and child primary key. That's why it makes sense, because he is using both tables primary key
So, okay.
like this.
Yeah, let me bring this one up. So here, is this like the engineer employee? Can we use this one as an example? Actually, I have
No,
a...
this is complicated. This is inheritance and
No, you will just use these things.
Employee and department as an affiliation? Okay.
Work.
Okay, so employee
And project.
works on project. Okay.
Fine. So their relation is one to many, right?
Yeah.
There is one to many.
So I can have one employee working on many projects.
Yeah,
Okay.
but and at the same time, one project can have like many employees. So it's actually many to many relation.
Now, how do you see that one project can have many? Oh, yes.
Yes.
Wait, no. I understand it in one direction, but shouldn't this be the other way around then? That one, it should also be an n comma 1? Yeah, so my question is, when I read 1 comma n, I'm thinking the 1 is on the left side, so it's relating to the thing that's coming from the left, which is employee, and the n is on the right side, and it's going to project, which is on the right. So to me, this is still saying one employee to many projects.
yes.
The same as this one. I'm not seeing any difference.
Okay, here's another way to look at it. You can look that one is representing the table to which it's close to, and don't think of the right left.
Okay.
Like one is for the employee. From employee's perspective, it's one too many. But if you look at the project's perspective, it also wants to say the same thing about itself.
Okay. One project for one department, but department has a one-to-many relationship with
Oh, yeah.
projects, which means that you can have one-to-many. I can have one department that has many projects, but a project can only be part of a single department.
Yes.
Okay, so
Absolutely.
1 comma n is always one-to-many of whatever box it's closest to.
So
Okay.
why is many to many? Because both are like
Both.
max value is like max.
Right. Now, why wouldn't they just show, I guess I was thinking like, why not do an n comma n? But that's almost like you only have the information of what's nearest me. All I know is that the employee is one to many, and I'm not going to take in anything else, because I guess maybe my relationship with projects or projects' relationship back with employees can change. And so I don't want to have
Encode this both
constraints that are
information.
like too far reaching.
Yes.
So I'm keeping my scope tight and saying, instead of saying n comma n. Okay, cool. Cool. So far, so good. And then we have this intermediate table. Okay, so here's one of the things that I started getting a little bit confused about.
This
Here,
doesn't necessarily need to be an
Yeah.
intermediate table.
Because-
Like it can be a separate table as well.
sure, I'm fine with that not being an intermediate table. But here where we start like doing the underlines and things, I got confused because here we're saying that livre d'auteur, my understanding, does this mean that the key of this table is ISBN and author?
Yes.
Because then when we're calling it here, why don't we say livreauteur.isbn auteur? Like, is this, what exactly, how do you have two columns as a key? How does this work?
When like you, when a single thing doesn't work, single primary key is not uniquely identifying something. In that case, you need something composite, like the both thing will uniquely identify your rows.
So when I'm applying this, okay, I can almost think of like first name, last name. There might be a lot of Adams, there might be a bunch of different Bruniewskis, but there should be, let's just pretend everyone has a unique first name, last name. There can only be one Adam Bruniewski. And so in that case, I can't take one, I can't take the other, I have to take the combination of both. So when I'm applying it in practicality, is it actually taking these two items and like squashing them together, or is it still considering them as two separate items? Like it's two separate, I don't know what you, not a tuple. What's inside of a tuple?
No, not inside a tuple. Inside a tuple is a like columns,
What's one column of a tuple? Is there a name for that?
row.
What's one tuple of a row? Like, what is one cell? What do you call
Cell.
one cell? Okay, do I still have two separate cells?
Yes,
Okay.
because they are in different tables. So think of it from this perspective. Like, why do you need a identifier or primary key in the first place? So that the database and user can uniquely identify a single row.
Mm-hmm.
So by making them both a key, first of all allows you to add multiple ISBN, because if only this was the key, then you wouldn't be able to add multiple authors book.
Yes, exactly.
Can you say what he just said in different words for me?
Like for example, a book has its own ISBN, right?
Mhm.
But in that book there are many authors.
Yes.
So if you just use that ISBN as a primary key, you will not uniquely identify that book.
Which tuple I'm actually referring to,
Yes.
because I have it's
Many authors.
repeating. I'll have the ISBN showing multiple times because I have a different author. Okay, so I'll have John, Lucy,
Like I
and
want to uniquely identify book one.
yeah.
So if you want to uniquely identify book one, so you have to like pair it with, right?
But if it's
Yes.
if it's uniquely identifying book one, you can just use the ISBN.
No,
No,
because ISBN
because
will
you
be
have-
repeated for.
Yeah, repeat it.
So you can think like this is Adam Bronsky.
Yeah.
Like
And
this
like-
author name is
Oh no, not Adam. Adam is
it's,
not.
it's like ISBN one.
This is
For
Professor
some-
Zamyani's book, Advanced DB.
Again,
Hold on, one person at a time.
okay. This is book one. Its ISBN is one.
Yes.
Again, after some rows, there is another author for this book, A2.
Uh-huh.
So you will use that ISBN again, right?
Yes.
So again, after some rows, again this ISBN is being used.
Because there's
and
author
A3.
three. Okay.
But these three in growth tuples is actually meaning this one book.
Yes.
So if you want to uniquely identify that, then you will have to pair it with the author.
You won't be able to add other two ones if this is the only unique key, because if one is
Right.
unique,
It's
so the
repeating.
table won't allow
Right.
another one in.
If I'm looking to define all of the authors that have worked on a book, I
Mhm.
can't just use ISBN as my unique ID because it's going to be repeating.
Yes.
And you
Okay.
can't use author.
I can't
Correct.
use just author because they're going to be repeating for different
Yeah.
books as well. Okay. Okay. So then when I'm connecting this, I'm still referencing, I'm not because I'm referencing back to the original, to this book table, I'm not having to use this ISBN author key. I can just use the ISBN key because
Yes.
that is what's uniquely identifying each book.
So think of this constraint from a perspective of trigger. Like this is for the trigger, that it needs to make sure that any ISBN you add to here needs to have an identity in the leaf table. So maybe I was feeling fancy and I added ISBN 89.
Mm-hmm.
There is no book 89 in the leaf table.
Mm.
So someone needs to point that out.
Okay.
This constraint won't help you point that out because I can come up with an ISBN and author
Yeah.
and enter.
Do you
it
say
in
this
the-
constraint will not help me see that or will?
No, it will not, because I can come up with two unique thing like ISBN on author and insert the row in the table, but the table wouldn't know.
I
Because
lost you on that one. I think
It's not necessary.
let's keep
that
going.
You are trying to explain. I understand, but
Yeah.
we will like
No,
confuse.
I'm
let's
thinking-
I think for the time being I'm okay at this. I'm still a little bit fuzzy on maybe like a nuance, but I think it might become more clear as we keep going.
Okay.
So let's keep going on it because I think
And I asked Victor, "What's this?" and he was like, "Don't look at it. Don't look at the slides." Oh no.
this
Okay.
question you guys already
This is
explained to
clear.
me.
I
Yes.
already.
Yeah,
There
yeah,
was
yeah.
another question like this, and that was
Okay,
this.
so now translation of composed attributes. So this is saying that in address, I have the road, the city, and the country. Okay. And now the question is, how do we translate this from a conceptual model into a relational model? And the way that that is answered here, I think there was a couple different ways of doing it, but one of the ways that I can do it is I can create a table called client that has, what did he end up saying? He almost like just kind of, rather than having an address, its own address table, kind of concatenated that there's a address street and address city and address country. But I think he also showed us a different way of doing that maybe further along. There's nothing special here though,
No,
right?
nothing
This is just
special.
straightforward. Okay. So then we're talking about translation of one-to-one or one-to-many. We may have already covered some of this. Translation of one-to-one to one-to-many. Okay, so here we're saying I've created a department table that has DNO as my primary key and name, and it has a one-to-many relationship with employees. Employees are going to have SSN and name, and they have a one-to-one relationship with departments. So one employee can only be in one department. Makes sense. And then
But
Mhm.
1 to n means a department can have
many employees.
Yes.
And so it's for that reason. So as soon as I see this one-to-many on the department side,
Mhm.
that's why I have to add in that's why I have to add this, the
Yes,
department.
foreign key.
I'm adding the foreign key into the employee because I have a one-to-many.
Many relations.
And then because it's in there, I'm basically, I need this here in the table so that I can actually reference that this employee here is part of this department here.
Always
Yes.
Remember that when a relation between two tables is like 1 to many, this one is the parent and this is the child. So you have to use that
Can I take
parent table's primary key to its child as a foreign key. For example, it's saying department number references department DMO.
Mm-hmm.
So I'm using this primary key
Mm-hmm.
as a foreign key here.
You're using this primary key here as a foreign key here.
Here.
Foreign key.
Yes.
I will make an example.
So this SSN is my primary key.
For this
But if I
employee.
have, let's say that my employee has a whole bunch of things it's connected to, and
Mhm.
each one of those things has a one-to-many relationship with employee, then I would end up with a whole bunch of foreign keys.
Mhm.
It's almost like giving someone the key to the city. They're not a citizen of the city, but they're an honorary member of it, and they always have access to it.
Yes.
That's a okay metaphor. I can do better.
Look at this example, like, so what if I want to make an employee? So these are the only possible departments.
Mm-hmm.
I want to add here 4. This constraint will not allow this. How will it do that? Because it knows that it's a foreign key. So it is foreign, the real key is here. Any entry
Okay.
made here needs to be
And this is what you were
Yeah.
explaining earlier.
Yeah.
That by having this relationship and having these foreign keys,
If the thing Smile is trying to tell you, it's called referential integrity maintaining.
okay.
this is the same thing.
Yes. Okay, so this is where we're maintaining referential integrity. Because I have a foreign key, it's not just going to let me update my table and say, oh yeah, sure, no, Ismail is part of Department 4, no problem. It's going to say, let me just check the department table first and check, do I have a Department 4? Yes, I do. He's in. No, I don't. I'm sorry. That is an error. And so this is basically coming back to our constraints now. So it's not a trigger. It's basically a check or it's
Yeah,
this is
constraint,
referential
referential
integrity. Okay. One-to-one association. If one is optional, the reference is this the sentence that Victor said don't worry about? Or what do these sentences mean?
I don't remember.
If one is
association.
optional, the reference goes to the mandatory side. One to many if the reference goes to the one. Okay, hold on. So this is what you were just telling me a second ago, Kush, that I have a one to many. So there's one department with many employees. So the reference is
Will
going to
all
the
go to
one
main
side. Oh, okay. I think if I had
That's I'm telling about parent and child.
yes,
relation.
but if I had a one-to-one and a one-to-one over here,
Mhm.
the reference goes to the mandatory side. What's the mandatory side?
I think it was trying to say if there is 1-to-1 here
Oh.
and 1-to-1 here, so this might take like
I think I'm thinking that if one of them is optional, that it exists. So let's say that an employee has to only have one favorite flavor of ice cream, but there's always
no,
that's a bad example.
sorry, I forgot this. Okay, so this we are interpreting it wrong. This diagram particularly shows 3 tables because now what you were saying works for is involved.
That's your intermediary.
Yes.
Okay.
So what it's saying is one-to-one. I don't know about the sentence below, but one-to-one.
Mhm.
So what it's saying is that okay, Ismail was working in one. I entered Ismail here. Now
Mhm.
I want to enter Ismail here again.
Mhm.
It said no. Although one exists here,
Mhm.
I won't allow you to add one more one because it's one-to-one. You can't do that.
Okay.
So
Okay, for that, like this explanation was not wrong. It's also right.
but
But if you
we will add one here,
if
and
you
Ismail's
want,
code will be. Yes, continue.
if you want to add that intermediate table, then you have to use. What are you doing?
Like correcting, because here employees unique number will come, and here the department DNO. This will be the department.
Department's primary key, right? And
Yes,
there is
this is a foreign key to this, and this is a foreign key to this.
Yes, that intermediate table. For
Mhm.
intermediate table, always you have to use that both tables primary key has.
Yes.
Yes.
And you'll have nothing else other than just a table of two primary key. Two, I guess, to the table works for. Sorry, in the table works for. It will only have two foreign keys.
Yes.
The SSN from one table and DNO from other, and it has none of its own. It doesn't need any of its own primary keys because it's just an intermediary table.
Does it need it? No, because it's only connecting these two tables, right?
Its whole purpose is to connect the table.
Yeah,
Okay,
yeah,
let's look at the many to many. Okay, so the only thing that changed here is now that I'm going to have, it's saying that one employee can be in multiple projects and one project can have multiple employees. So this is standard. The employee table is making sense. The project table, oh, actually, hold on. Why does the project have, oh, the name, okay, hold on. The project has both a project number that is a key as well as the name of the project is a key. I wonder if that's a typo. I think I remember Victor saying that there are typos around here. But, okay, let's just keep going.
Yeah.
So then we're creating because it's a many-to-many, we're creating a new table called employee project. Now, is employee project, is that different from the table works on?
No, I think
it's
these are the
same
typos. He wanted to
Man, this thing is riddled with typos. That is
Employee
not
project.
good to have
Yeah.
typos in such a
Delicate.
very delicate moment
Yeah.
of my life. Okay, so this is, thank you. This employee project is the works on table. And it's going to have the SSN from one, and I think that name is also, this is not, shouldn't be underlined.
Yes.
So it's having this is exactly what you guys were just saying, the primary key of one, primary key of the other, and then it's saying that the SSN is referencing this SSN, yeah, and this Pino is referencing that Pino. Great. Careful that you can't, this is not the same thing as this. Okay, yes, so this means that these things taken together are a primary key. This is saying that these two individually are primary keys.
Yes.
I don't know about this. This was
Yes,
statement that Victor was like, I don't know, don't
But
look
I
at
know,
this.
I know.
I because
The previous example about the book ISN and book author, why we use these two together, because we already give you the reason, because one ISBN under there are many authors.
Yes.
So in those cases we use that together primary key.
This one, yeah.
And this case is we can use that uniquely, and you can use this uniquely identify. Like we don't have to identify row like.
I can have multiple keys for a single tuple.
no, I don't think that's a thing in database.
This number
SSN.
can have only one employee, like the employee one have this number one. It can't have any other employee, right? And for that employee, the department number can like 1. So if I use this works on table, so I will know that is the relation between these two is like uniquely, I can uniquely identify each row. Like I don't have to use it uniquely identify this row with this prime.
That's if it's a one-to-one relationship. Because if you have multiple or if you have one department with many employees, you could only use SSN as your unique identifier.
Yes.
Did he? I wonder. Did they mean to make that red?
Yeah.
Because if this were red, then I would understand this as just saying you have one primary key and you can have several foreign keys also, but you need to underline them together for it to be a combined.
This is just confusing because.
Okay, let's leave this. I'm
Let's
going to leave
leave
this
this,
as a
yeah.
question. If it's confusing, let's leave it as a
But
question.
I understand, but I can't give you the
Okay,
correct
that's cool.
answer.
That's cool. No worries. No stress. Okay. Now we're translation of generalizations. Is this a solution?
Yes.
Oh, okay. This is the example. Okay, so great. And I think there's a bunch of typos in here again, which was super annoying. Okay, so he has a table employee with SSN. Decided to, I'm assuming there were other options in there and did a whatever. Birthday address didn't exist, but there's an address, sure. Then they're saying that secretary, I forget, what does the T and the E mean?
It's mean exclusive, like you can one of this at a time.
Oh, employee can be exclusively a secretary or a tech or an engineer. Okay. So then I have
T also meant something. T was
total or exclusive.
total. Yeah, total.
what does the total mean?
I don't know, but I
Okay.
remember that
Okay.
So
exclusive.
we need to
word.
understand the problem being solved. Like
Okay.
I did this with Richard.
So then I have a table called secretary, and it is going to take on all of the things that exist in employee.
Can I explain one piece that we're missing here? So this is the they're trying to show you the problem is that the manager is facing, that he needs to store employee and he also needs to associate a role with employee. So there can be an employee secretary, employee technician, and employee engineer.
Mm-hmm.
So now this will tell us 3 ways of solving this. Like how do you encode this information in the database? Because to me intuitively it was like maybe I will add a column in the employee table
Mm-hmm.
and add a row there. But now they will tell that there are other ways as well. And when you make other tables of different roles, like you could make an employee secretary table,
Right.
an employee
Okay.
technician.
So we're about to, yeah. Okay. So what I'm hearing from you is that the problem is basically that I have, like you said, employee is going to have one of these 3 roles, and they're about to show me different ways that I can show that,
not
and
actual
it means the
schema.
exact same thing.
Yeah, and the thing about T is you were asking. So T means that an employee has to be one of these 3.
Okay.
If it was an I, it could mean that it is possible that an employee is neither.
Okay.
It's just an
So
employee.
T means it must be one of these 3, and E means it's exclusively only one of these 3.
Yeah.
Gotcha. Okay. So then I have a secretary table, and since it's taking on you already have these employee attributes, the child is just adding typing speed, tech is tech grade, engineer is engineering type, and then the references. This is pretty straightforward. It makes sense to me.
This is solution 1.
This is
according
solution
to-
1. Okay. And then it said plus integrity constraints.
Like the TE, I think.
Okay. Okay.
So,
So then the next solution that they looked at, or the other way you can do this, is to have okay. So then you almost like collapse these onto each other, and you have a secretary table, a tech table, and an engineer table.
Tables, like
Yeah.
BDMA.
Sorry?
No, it's like we are just the previous side we are just using the SSN.
Yep.
And we are giving more attributes. Like I understand these things that. way.
Well, now, because what I'm understanding is here I have 4 tables. Depending on which role I'm in, I'll then fall into. Wait, secretary has the SSN. Yeah, so it's just going to add on that, secretary number 5 has a typing speed of X, technician number 2 has a tech grade, whatever. So then I have 4. Whereas here, they're saying we're not going to generalize this employee table. If you're a secretary, you're going to end up in the secretary table, a tech will be in the tech table, and an engineer in the engineer table. And each of
That's
them are
what
going to
I
have
With
a
all the
different,
details.
Yeah.
with all the details. Okay. And then that was solution 2. And solution number 3 just had one table, and then it added on so in this table you might end up with either a 0 or a null in 2 out of 3 of the columns. But your T and your E, okay, so this is my table, and then I'm assuming that my integrity constraints are whatever I need to make the T and the E to work.
Yes.
Which
Now
means that
this
it'll
makes
say
sense,
thou shalt have at least 1 typing speed, tech grade, or eng type, but no more than 1.
yeah, and it
and
has
here-
to have 1.
And here, for this one up here, I might have to do it differently to say if there's an SSN in secretary, it cannot exist in tech or engineer. So my integrity constraints are going to change depending on how I set my tables up.
Yeah, what design you choose.
Does that make sense, Kush? Cool. How close are we? Please tell me we're close. Oh.
You're close.
Okay, this is good. This is really good. This is really good stuff. I really appreciate this. Okay, translations. What can we say about these generalizations? Oh, total means it has to be part of one of it. Non-exclusive means it can be part of multiple.
Yes.
Yeah.
So that would be someone that can be both a secretary and a tech,
Yes.
but it has to be at least a secretary or a tech or an engineer.
Hmm.
Partial and exclusive. Exclusive means it can't be a tech and an engineer. It has to be only one of those. What does partial mean?
It can be neither.
Oh, it can be zero?
Yeah. This is
So total
from my
means at
decision.
least one. Partial means can go zero. Is
Yeah.
that... Sorry, you said for
to
my...
my best remembrance of the discussion with Victor. I think we can,
Should I mark
Yeah.
this as a follow-up question? Okay.
Yes, because I wouldn't want to mislead.
Sorry, I don't mean to
No, I don't want to mislead.
Yeah.
either, so
And I don't want to
100%
question.
up
Okay.
to-
Okay, and this made no sense during the during our exercise because it was last week, and he just dropped this on us like it was supposed to make sense. But now that we had a whole 2 hours to talk about it, it suddenly started making sense. So now I get this part.
Which one?
Just generally what this table is showing. So were you at the lecture today?
No.
Okay, so this will be a great opportunity for me to see if I can explain all of this.
Okay.
Yeah.
Let me just see if there's any difference here between these two slides. Okay. He just gives a solution. So I'll just go to this one. So when you have one of these guys, it's saying that this is the existence of employees temporal. The way that Esteban's been representing that, again, maybe I'll take a step back. All of these conceptual diagrams, anytime you ask when you're looking at a conceptual diagram, would that mean the table looks like this? You're asking the wrong question because a conceptual diagram is always conceptual. The way the tables are formed does not matter at all at that point. And we just saw that in those three different solutions. So the whole point is to try to be high level enough that you can talk with a manager and just work through the big picture. So the way that he represents here, it means the employee is temporal, means that there's a start time and an end time. Today he went into even more icons that show that it can be continuous or discontinuous. You can have an employee that worked from January to April and then took 3 months off for sabbatical and then was working again. So
it's continuous.
that would be discontinuous.
Discontinuous.
Yeah, so it has a start,
Okay,
end,
break.
pause,
Yeah.
start, end, yeah.
Okay.
So up here he's showing that this employee has been working from 7-94 to 7-98. Then name and birth date are non-temporal, they're just what they are. Address is temporal. So this means that every single time that you have an employee, you're also going to have to store the address that they lived at for all the different times that they lived there. And now how do you structure this in a table? It doesn't matter because we're talking about a conceptual diagram.
Okay.
Same thing for salary. So this is each salary with each time period, and same for projects. In this case, there was a one to many, which means I can have one employee working on multiple projects. So here you see from 794 to 895, they were only working on one project, MADS, but from 995 to now, they're working on 2 projects.
Okay.
So that's really, I think, in terms of what we went over here, that's all that really mattered. Okay, and so now he's giving a solution of how can we show this information. So he creates an employee table that has the name. Because it's temporal, it has a start time, the birth date, and then an end time. Okay, great. And this is, I guess, also assuming that it's continuous, but we didn't get into that on this exercise. Then created a table called employee address with, I guess here they're using the name as being a key, and has a start time, the address, and the end time. Then the employee salary, name as, he's using both of these, name and start time as being the key. Yes. Yeah. Salary end time and then project end time. Okay.
Because entries in these tables, all of them will repeat.
Say that again. Different.
Entries, like these rows.
Yeah. In which
will,
table?
In all of them. That's why you need 2 keys. Because if you only had 1 key, you wouldn't be able to repeat.
Oh, right. Because the address, if I only had name, then it wouldn't be a key anymore because I'm going to have 3 addresses.
No, it would be a key, but you won't be able to add the next address.
Well, no, it wouldn't. Well, okay, so it would be a key that doesn't work because I
Just
think it
an
makes sense.
FYI from my discussion with Victor, because he saw the solution as well. The lower part, engineer and administrative part, this wasn't even in the solution. He was really pissed at the team.
Yeah. And I think there was.
They gave us a problem that they didn't solve themselves. And
Yeah.
he said that it was impossible to solve. Like, it was very difficult. Decomposing the employee into engineer and administrative. So we can skip that and do rest of the part.
What does. Oh, dependent. So this must have been the example he gave today in class. Dependent as in, do I have a daughter or not?
Yeah.
Okay, that annoyed me. Because when you use the word dependent, I was thinking parent-child, like database parent-child. And I was just like, wait, what does it mean that administrative is dependent of employee?
But why is it temporal? Why dependent is temporal?
How would I...
Maybe you have a wife now and
They could die.
Yeah.
Maybe you started working single, you started working without children, and then a child was born while you were working. So it's temporal in that sense. Okay, no, this has been really good. Okay, so basically what we went over is this is a temporal conceptual model that's showing me what kind of... So relation or name, I think makes sense. And what you were saying is that from a business perspective, how you set this up depends on what matters. Depending on what you're focused on might change the way your conceptual diagram looks.
Yes.
Okay, so we have a temporal conceptual diagram that's showing the relationship between our major concepts or major relations. It's able to show one-to-one, one-to-many relationships, whether they're temporal. And we're able to take this information, and depending on what kind of relationships that we're seeing, we can start to think about from this creating a relational model that kind of defines which tables will exist and what kind of constraints, integrity constraints will I have. Integrity constraints including things like total, exclusive, and references between foreign and primary keys.
Yes.
Does that sound
Okay.
Comprehensive enough to encapsulate all that we've done.
That was a great session. And that was like 45 minutes. Oh man. Okay, I get it.